Title: Cyclopentane as a refrigerant, a comprehensive assessment of safety, advancements, and environmental impact. 1. Production. Cyclopentane, a hydrocarbon compound, has gained significant attention as a potential replacement for traditional hydrofluorocarbon (HFAC) refrigerants, due to its lower environmental impact and improved energy efficiency. This report aims to provide a detailed investigation of cyclopentane as a refrigerant, focusing on its safety profile, historical background, benefits and drawbacks, and practical applications. 2. Safety profile. Cyclopentane has certain safety considerations that need to be acknowledged. Its main hazards include flammability, potential explosion risks, and its high volatility. While cyclopentane is classified as a flammable substance, its safe utilization is possible through adherence to specific guidelines and industry standards. These include proper handling procedures, adequate ventilation, and suitable leak detection systems. To mitigate potential risks, refrigeration systems using cyclopentane should incorporate advanced safety features such as explosion-proof electrical equipment, vapor detectors, and appropriate access restrictions. Regulatory bodies such as the International Electrotechnical Commission (IEC) have developed safety standards to ensure proper handling and storage practices. 3. Historical background. Cyclopentane as a refrigerant began in the early 1990s. Following the phasing out of ozone-depleting refrigerants like chlorofluorocarbon (CFCs) and hydrochlorofluorocarbon (HFCA). These substances were replaced by HFCs, which had lower ozone depletion potential but higher global warming potential (GWP). However, in recent years, concerns about climate change and the need for environmentally friendly alternatives have shifted focus towards cyclopentane. Notable advancements in cyclopentane's application as a refrigerant include the development of low GWP foam blowing agents for insulation and the use of cyclopentane in domestic appliances like refrigerators. Continuous research and development have led to the optimization of cyclopentane in terms of its safety and efficiency. 4. Benefits and drawbacks. 4. 1. Energy efficiency. Cyclopentane has superior thermodynamic properties, resulting in better energy efficiency compared to HFCs. It exhibits higher heat transfer coefficients and lower compressor work requirements. This translates into reduced energy consumption, contributing to lower operating costs and decreased carbon emissions. 4.2. Environmental impact. Unlike IFs, cyclopentane has negligible ozone depletion potential and a significantly lower GWP. Its global warming potential is only 3, compared to JUPs above 1000 for common HFCs, like R134A. The reduced environmental impact of cyclopentane aligns with international goals to combat climate change. 4. 3. Cost effectiveness. Cyclopentane expression costs are relatively competitive, enabling cost-effective implementation. However, it is important to consider factors such as regulatory compliance and potential additional safety requirements that may impact overall cost. 4.4. Drawback. Flammability. Cyclopentane's flammable properties demand careful handling and appropriate mitigation measures. However, when the correct safety practices are followed, the risks associated with handling flammable substances can be managed effectively. 5. Practical application. Cyclopentane has found successful application in various refrigeration areas, such as domestic refrigerators, commercial coolers, and freezers, and as a foaming agent in polyurethane insulation. Manufacturers have successfully implemented cyclopentane in refrigeration systems, reducing both their environmental impact and energy consumption. 6. Recent studies and industry data. Recent studies have supported the positive attributes of cyclopentane as a refrigerant. For instance, a study published in the International Journal of Refrigeration indicated that cyclopentane Based systems exhibited a 20–30% reduction in energy consumption compared to traditional refrigerants. The research also highlighted the minimal environmental impact of cyclopentane. Leading refrigeration equipment manufacturers have shifted their focus to cyclopentane-based solutions. Due to its superior energy efficiency and environmental considerations. This shift is indicated by statistical data demonstrating an increase in cyclopentane usage in refrigeration applications worldwide over recent years. 7. Conclusion: cyclopentane has emerged as a promising alternative refrigerant due to its energy efficiency, lower environmental impact, and acceptable production costs. While flammability is a potential concern, with proper precautions and adherence to industry standards, the many benefits of cyclopentane can be safely harnessed. As the world acknowledges the importance of transitioning toward eco-friendly refrigerants, cyclopentane's practical application across various industries demonstrates its potential as a sustainable solution. By utilizing cyclopentane as a refrigerant, businesses can achieve significant energy savings while contributing to global environmental goals. Although the decision to adopt cyclopentane ultimately lies with stakeholders, the evidence presented here urges readers to consider the potential advantages and drawbacks. With a balanced assessment of safety, energy efficiency, environmental impact, and cost effectiveness,